Okay, so we started out last class talking about ratios. We looked at a recipe and it asked us to switch how to make double the amount. So we knew we needed to double the ingredients. We knew if they asked us to do half as much, we'd use half. If they asked us for kind of a strange number, we'd have to do the ratio and figure out how many times bigger there are. So what we're going to do with this is just use these ratios to predict how much of something should be made, or knowing how much something's made, figure out the reactants. So in our chemical reactions, mass and atoms are conserved. That's why we need a balanced chemical equation. So in this, we need to know we have reactants, and they turn into products, and we need a ratio. This ratio can be atoms like a particle diagram, but what's more useful to us is moles. So in the lab, we're going to use moles or make a molar ratio. So an example of this would be this equation. Whoops, it looks like it took my arrow away. That's actually an arrow. 2 moles of magnesium are burned, so we're going to take that and add it to oxygen. So that's some weird font thing that had some issues. And we know that with those coefficients, that 2 moles of magnesium are burned with 1 mole of oxygen. Now again, they're not going to show us that 1. I just put in parentheses to remember if there's no number, it's 1. We're going to make 2 moles of MgO, or we know the ratio is 2 Mg to 1O2 to 2 MgO. So for this relationship, we're going to make predictions about how much we've used of something or how much we can make. So to do this, we're going to need these ratios. So for this, they're going to give us a number. They're going to say you have 12.2 moles of sodium or something like that. And they're going to ask you to find something like chlorine on that. So we're going to take that number they give us and then do the coefficient of what you want. So if they gave you magnesium and they're asking about oxygen, put oxygen's coefficient on top. And the bottom is going to be the coefficient of the given number. So if they told us Mg to start with, we look at the equation and see that there's 2 Mg. So we've got some problems that we're going to do with this. So the first one is, if I have 6 moles of magnesium, how many moles of oxygen are needed? So what I would do first is I would write out what I know, 6 moles of magnesium. Then I'd use my equation on here. And again, my equation was 2 Mg plus O2 yields 2 MgO. So I am looking for oxygen here. So I'm going to write down which I know, which was the 6 moles of Mg that was given to us. I'm then going to use my coefficient. So it's going to be the coefficient of what I want to find, which is oxygen. And there's no number here, so we know that that is 1. For magnesium to cancel it out, we look over here, and its coefficient is 2. So that's why I put this here. I multiply on the top and I divide on the bottom. So 6 over 2 is 3 moles of O2. Now I can also give you a product. So in this case we have 10.3 moles of MgO. And so we're looking for Mg, which again was a red number, and it's 2. But this time we're also using MgO, and its coefficient was 2. So this is a 2 to 2 ratio. We know if you get 2 for every 2, they're equal. So the answer here would be 10.3 moles of Mg. Okay, they can also give us how much you use of something. That was the excess reactant. So if I consume 5.4 moles of oxygen, how many moles of magnesium must have been used? So again, we're looking for oxygen and its coefficient on here, or I'm sorry, I used oxygen and I'm looking for magnesium. So since I'm using oxygen, use its coefficient here too. I'm trying to find Mg, which is the red. I'm going to take 5.4 times 2 over 1, so that's 10.8, but my sig fig rules say I need to round that to 11. Again, sorry about some of these weird figures this is putting in here. O2, I'm going to start out the exact same way, which means I'm also going to use the 1 coefficient down here, but MgO is a 2 to 1 ratio. So same answer here, 10.8 moles, but we'd round that to 11 to have 2 sig figs. So for these ratios, we're going to organize them in a table, and this table is going to be really helpful when we move on to some longer equations and figuring out how much we run out of something. So this is called a BCA table, before, change, after, BCA for short. So before is what we have in the beginning. You're going to write down the given amounts. Change is how much you actually use, and after is how much is going to be left over on here. So it's going to look like this, balanced equation, and then before, change, and after. Okay, so let's look at an equation. So hydrogen sulfide gas burns in air to produce sulfur dioxide and water. And we want to know how many moles of oxygen gas are going to be needed to completely burn 2.4 moles of the hydrogen sulfide. So you need to balance this first. O is going to be the harder part because it's in 2 spots. Notice on the left it's O2, so that's always going to be even. So the first thing I did here was that I put this 2 here to balance out the O's and make it even, because before there was 2 on one and 1 on the other, so I know I'm going to make that even. That 2 means I now have 4 hydrogens, so that's why I put the 2 here. That gave me 2 sulfur, so I put the 2 here. And then don't forget 2 times 2 is 4 plus 2 is 6, so 3 times 2 gives my 6 in here. All right, so we're ready to do our BCA table. So the first thing we do is fill in the before line with the given information. You do not have any products yet. They haven't been made yet, so we're just going to put in 0. Okay, so I put in what I know, which is 2.4 moles of H2S. Oxygen, it's told us excess, or else there's no info, so excess, and then the 2 products are 0. Okay, so anything you have more than enough of or no information for, you're going to write excess or the letters excess here. So now we're ready to do the change line, and for the change line, we are going to use our coefficients, and you're going to start by subtracting the original amount here. We're going to have to do ratios like I was showing you on the previous page. So for H2S, that's the only one we have a number for, so we're going to do minus the 2.4 that we had. For oxygen, we're going to take the 2.4 moles of H2S times the 3 moles of O2 to the 2 moles of H2S. And that's how I came up with 3.6. For the other two, I'm still going to start with 2.4 moles of H2S. And then these both have a 2 to 2 ratio. So 2 moles of SO2 to 2 moles H2O, 2 moles of water to 2 moles of SO2. Okay, so that's how I got that line. And if it's on the left side, I subtract. If it's on the right side, I add it. Now finally, I'm going to combine those 2 lines. And then, so if I have 2.4 and I use 2.4, if I have 0, excess minus any number, still excess. We know we have more than enough. And then the change line is going to have that same number on there. So we were asked to find how much oxygen was actually used. So this is our answer right here. Whoops. Probably should have used the highlighter there. And our answer then is going to be this 3.6 moles here. Okay, so a couple other examples on here. We've got hydrogen and chlorine making HCl. We were told we have 5.2 used, so if we used it, that's how much we had. Hydrogen has to be excess then. It's a 1-to-1 ratio, so we got 5.2. For HCl, it's a 2-to-1 ratio, so you'd get 10.4. We're only allowed to keep 2 numbers, so 10. And again, we really should keep the sig figs here, make it 10 or 10 with the dot. For chlorine, how many moles are actually used? That would be 5.2. All right, one more example, calcium and phosphorus, and we had to work this one backwards. So on this one, sorry, the split kind of weird. We were told we had 1.5 moles, so we made 1.5 moles. 2-to-1, so 3.0, and then 3-to-1, 4.5. So we need 3 moles, and then the 4.5 moles. Aluminum sulfur makes aluminum sulfide. We had to balance that out, so 2Al and 3S. We were told on this one that we had 4.44, so I need to do a 3-to-2 ratio to get 6.66, and then a 1.2 to get 2.22. So final answers here, how much sulfur was reacted, that would be this answer here, 6.66 moles, and then how many moles aluminum sulfide are made at 2.22.